Welcome, ladies and gentlemen, my friends, students, teachers, and colleagues. Welcome to VINDAL'S Academy, and today I came with a very good and important topic, differentiation. And today we're going to be looking at the first principle. And this first principle, we're going to find how this is made possible. And most of the times, this is what leads to the equation which we use, or the formula method for finding differentiation. And for those of you that will be asking myself, what am I doing with this kind of thing? A whole lot of applications are needed. But you don't know it, don't criticize what you don't know. Let's get started. All right, I am going to start by saying y plus change in y. Now, we have two quantities, y and x. Whenever a particular quantity changes, is going to cause a change in the other quantity. Remember what is called in economics, even in real life. So this is going to be equal to, for x is going to be x plus change in x, all raised to power n. This is where the problem comes. But before then, remember, I'm looking for the y, which is something as this, change in y. So I'm going to say dy is equal to x plus change in x, all raised to power n, minus y. Remember, I am making the y the subject formula. So I have to subtract y from both sides of the equation. And that is why y, I'll simply say, remember that was plus here, when it comes here, it becomes minus. All right. So after that, now the question is, what is y? Y is already given as x raised to power n. So I'm going to say that change in y is equal to x plus change in x, all raised to power n minus x raised to power n. Okay, now we are here. At this point, I am sure you must have seen something like this, 1 plus x raised to power n. You know, whenever a power of n is there, you don't know what that n is. It could be an integer, it could be positive, it could be negative, it could be less than 1. So let's assume that this n can be anything. So we are not going to restrict it by only positive values. We are going to say that n may be minus 1 over 2, n may be minus 5 over 3. N can be anything. So for that reason, we are going to apply a binomial theorem. Now look at what we are going to do. In that case, I am going to say that change in y is equal to, I'm going to open this. How do I open it? I'm going to say that n combination 0. When I use combinational method of this binomial expression, see what I'm going to do. I want to make it simple. So what I'm going to do is, the first letter, x, is going to be raised to power n. Okay? Minus 0. Then multiply. The first one is multiplying the second one, changing x raised to power 0. See, the number of the combination of this 0, this is going to be minus whatever this is, and raised to power this, plus another one. So I'm going to say n combination 1, right? And this is x raised to power n minus 1, right? Then multiply by changing x raised to power 1. Remember, whatever this value is going to be the value here, is going to be the value, it's continuous. Remember, it's an infinite series. We don't know where it should stop, but I'm going to stop at a given point. So this is going to be plus n combination, let's say 2, 0, 1, 2, x raised to power n minus 2, changing x raised to power 2. Then this is plus going, okay? It continues, so we don't know where it stops. Also, after that, the next thing is minus x raised to power n. Alright? So at this point, the next time I'm going to, let's open this. N combination 0 is just 1. So we have change in y is equal to 1. There is no need to ask. You have x raised to power n. N minus 0 is still n. And anything raised to power 0 is still 1. So we leave this with this. So this is plus. N combination 1 is same thing as, look at the formula for this combination. I'm going to say n combination 1 is going to be n factorial all over n minus 1 factorial, and then r factorial. Let's say r, So I'm looking at this, the formula for combination. So since this is n, combination 1 is going to be n factorial all over n minus 1 multiplied by factorial and all over 1 factorial. So in that case, I'm going to open everything here to say is going to be, so if I solve this, I'm going to have n multiplied by n minus 1, right? Is still factorial all over this n minus 1 factorial times 1. So this cancels this. I have only n left. So this is going to be, everything here has been simplified to be n. Do you understand? So this is going to be x raised to power n minus 1 times change in x, right? So I'm going to do the same for here. For this number, for this particular one, I'm going to say n combination 2 is going to be equal to n factorial all over n minus 2 factorial then 2 factorial. So that is what it is. So let's simplify this. When I simplify this, I'm going to have n multiplied by n minus 1. I need to get the denominator. Then n minus 2 factorial. Let's stop there so that you can cancel with the denominator. I have n minus 2 factorial times 2 times 1. Or simply say 2 factorial. So this cancels this. I have this. So I'm going to say this is plus. I'm going to have n multiplied by n minus 1 all over 2 factorial times this, which is x raised to n minus 1 and change in x. Let me clean this part. Alright, so this, and this, so I think we've done with this, okay? I think, alright, so no, this is the one we dealt with. So this is going to be 2 minus 2 and change in x raised to power 2, then plus, keep on going, then minus x raised to power n. Alright, so this is what you see most times when you look at some binomial theorems. This is the expression you're going to see. So at this point, remember, n raised to power n minus n raised to power n. So let me just do this way to remove them. They subtract themselves to be 0. So the next thing I'm going to do is divide both sides by changing x. So I'm going to also divide this side by changing x. Divide this side by changing x. Alright? So now this is 1. So I'm going, if I divide everything by changing x, each of them will be divided by changing x. So this change in x is going to cancel this change in x. And this change in x is, change in x is squared. Cancel one of them. One left. So we have change in y over change in x is equal to, this is left, n multiplied by x raised to power n minus 1. Change in x is gone, plus, this is going to be n bracket n minus 1 all over 2 factorial times x raised to power n minus 2. Remove this. Let me use dot. And then change in x. Right. So after this, the next thing is to carry out the limiting function, the limit. So we're going to say that the limit, when change in x tends to 0, we're not saying that change in y over change in x, or we say that the y, the x is equal to this, n f raised to power n minus 1, plus, if this is 0, everything here is going to be 0. So, and we are left with just this. So this is the answer.